Welcome back. In this video, we're going to combine the chain rule with the existing derivative shortcuts that we've used already, including the quotient rule and the product rule. Now, these are challenging for a few reasons. Reason one is that there's lots of pieces. There's lots of things that can go wrong. But more important, reason two, the first step that you have to do is a step that doesn't involve any writing. It's a thinking step. You have to ask yourself, what type of derivative is this? Is this a chain? Is this a quotient? Is this a power rule? Is this a product rule? Is it more than one rule? And if it's more than one rule, you have to make a decision about which one's the big rule, which one's the small rule, and you'll see what I mean. When I look at this, I think that there's a big product rule that starts everything off. Yes, there's a chain rule in there because you see a bracket at the power of 9, but more important than the chain rule, they both are necessary, but I think more important when you're first staring at the question is to say, I have two functions multiplied together, so I will need a product rule. What are those two functions? The first function is x to the power of 6. I'll call that a. The second function is that bracket to the power of 9. I'll call that b. I'll write them down off to the side. A is x to the power of 6. B is 7x squared plus 8x to the power of 9. What does the product rule say? The product rule says that when we take the derivative of a times b, we'll have a times b prime plus b times a prime. So a, that's easy, x to the power of 6. I'm going to leave a big spot for b prime plus b, that's easy, 7x squared plus 8x. I'll leave a small spot for a prime. So a was x to the power of 6. That means a prime is 6x to the power of 5, so I'll put that here. B is 7x squared plus 8x to the power of 9, which is w to the power of 9. When we take the derivative of w to the power of 9 for b prime, we'll have 9w to the 8 times w prime, which is 9 times 7x squared plus 8x to the power of 8 multiplied by the derivative of 7x squared, which is 14x, plus the derivative of 8x, which is 8. And that's what will go in the bracket with x to the power of 6. So 9 times 7x squared plus 8x to the 8 times 14x plus 8. And that is the answer. I'm going to put at the top here, do not simplify. This is the way we would expect you to have your final answer on a test. Can you simplify? Absolutely. You can common factor out x to the power of 5. You can common factor out 3. You can common factor out 7x squared plus 8x. Oh, I lost something. I lost the power 9. Aha. This is now the answer with the power 9. Yes. So we can common factor out 7x squared plus 8x to the power of 8. And I think that's it. We'll be able to factor that stuff out. And then we would have other terms as the remainders and be able to add those together probably. But it's not necessary. Leave it alone. Leave it like this. All right. Classic. One of my favorites, and I think everyone's favorite. This would be your favorite too. A fractional function. So a rational function to a power. Every time you see a rational function, you probably think this is a big quotient rule. And you're right, it is. There's a quotient rule involved. But I think bigger than the quotient rule for this one is the chain rule. Because I'm going to identify this as a function to the power 5. I'm going to rewrite this as w to the power 5. With w equals x cubed plus 2 divided by x squared plus 2x. Let's see what happens if we take the derivative this way. H prime of x, according to the chain rule, will be 5w to the 4 times w prime. In class, the hand should go up. Sir, how come we didn't do a quotient rule yet? Like this is screaming quotient rule. Where is it? And well, it's there. It's inside the w prime. When we calculate w prime, we're taking the derivative of the expression in red. That's going to be where the quotient rule is hiding. So 5x cubed plus 2 over x squared plus 2x to the power of 4. And I'll leave a space for w prime. So this is a t over b type derivative. W prime is bt prime minus tb prime all over b squared. So the bottom function is x squared plus 2x. T prime, the derivative of x cubed plus 2 is 3x squared plus 0, but there's not usually a point to write the plus 0, minus the top function, which is x cubed plus 2, times the derivative of the bottom, which is 2x plus 2. All divided by the bottom squared. So x squared plus 2x all squared. We can take that and transplant that right into the box there. We'll draw that bracket when I know how big it has to be. So we have x squared plus 2x times 3x squared minus x cubed plus 2 times 2x plus 2. Trying to squeeze everything in. And then all divided by the bottom squared, x squared plus 2x, all to the power of 2. Big block letters do not simplify. Leave it alone. Don't mess with it. Now I'm going to give you some optional homework. H of x equals, distribute the power of the top and bottom, because you're allowed to do that. You get x cubed plus 2 to the power of 5 divided by x squared plus 2x to the power of 5. That's a t over b. Find h prime of x with a primary quotient rule. You may think this is the easy way until you realize that each of t prime and b prime require a chain rule. Another interesting thing about this approach is that the answer that you're going to get at the end, if you use this method, isn't going to look like the answer that's above. You'll get something that looks different. And then an optional task is to show that they're the same, to simplify both of them and confirm that they're identical. All right, here's another famous type of example. We're asked to take the derivative and it's messy. There's lots of parts. So before writing anything down, think a little bit. What type of derivative is this? What type of function do we have? Yes, we have functions raised to powers. We don't have any quotients, so there's no quotient rule. So chain, is that it? Just chain? Or is there something else? And the answer is there is something else. There's a product. There's really two functions there. And it's a product rule that is primary. I'm going to call the first function, x squared plus 1 to the power of 3, I'll call that A. The second function I'll call B. When we take the derivative according to the product rule, we get h prime of x is equal to a times b prime plus b times a prime. So I'll leave a space for the things we'll have to plug in, x squared plus 1 to the power of 3. I'll leave a space for b prime. Plus b is x squared minus 1 to the power of 4. I'll leave a space for a prime. And then we'll do those on their own underneath. So b is equal to x squared minus 1 to the power of 4. A is equal to x squared plus 1 to the power of 3. B prime will be, the 4 will come down. So this is a chain rule. This one will be a chain rule as well. So the 4 will come down. We'll have x squared minus 1 to the power of 3 multiplied by the derivative of the inside. So I'm going to take that and plug it in up above. 4 times x squared minus 1 to the power of 3 times 2x. And then for a, when we find a prime, we'll have 3 times x squared plus 1 to the power of 2 times 2x. Let's plug that piece in there. And that would be our answer. It says do not simplify, and it means it. One of the main takeaways is when you are starting off with all these derivative laws of product, chain, quotient, power, you should invest time before you write anything down to thinking about what the question is, what type of function is it, what type of rules do I need. Don't just launch into writing something. Give it some thought. And that might be 5 seconds, but you just trust me, you don't want to just launch into writing stuff down because your brain kind of shuts down a little bit when you do that. Okay, and we'll start the next topic in another video because it is kind of different.